Nailed it. Okay. Excuse me. So our homework for today was to go back to the old soccer game, the soccer team management tool, right? That we used to have parallel arrays. So when I say parallel arrays, what do I mean by that? So in terms of a problem-solving approach, when I say parallel arrays, what does that mean? We used to have one array for our jersey numbers, right? And then we had a second array for our player ratings. And those two arrays I would classify as parallel arrays. What was the, I don't know, what aspect of those two arrays made them parallel arrays? Go ahead.
Because the things at the different positions were supposed to line up, like the thing at bucket 0 with bucket 1 was 9.
Yep. So these arrays were the same length. And whatever element was at bucket 0 of one of them was related to what was at bucket 0 of the other one. Okay, so jersey number at bucket 0 here was the jersey number of the dude with this player rating at bucket 0 over here. Okay, so we can really look at those as almost precursors to object-oriented programming, right? Having this, what we moved to for this assignment where we created a player object. Now we have a single object that contains both a jersey number and a player rating, right? And we can also have more stuff than that. So instead of having a whole bunch of arrays for keeping track of a whole bunch of pieces of information, we can now have one array of players, and each player is self-contained in terms of that player's jersey number, that player's rating, that player's name, that player's statistics for scoring, that kind of stuff. We can have all sorts of stuff in those objects. Okay, so we had created our player object where we have our jersey number and our rating. Here's our constructor for this guy. Constructors do not have return types. Why not? They look a lot like methods, but they don't actually have a return type. Why not? Because it's always called with the new keyword. Therefore, it's always going to get a memory address. So when we create a player object like we did right here, here's the constructor that takes two integers. It's being called with our real estate agent who always gets us a memory address. So the value that's returned by the constructor is always going to be a memory address. So why should we waste our time putting something in here when it's always a memory address? Make sense? Okay. So we have our constructor, takes in two integers. We set those two integers here to the values. So all variables resolve to their most local definition. So this version of jersey number resolves to this guy. But this guy here, we've specifically thrown the this keyword in front of it that says bypass our local definition and go up to the guy up here. What are these guys called? Go ahead. Those are fields. So all objects are made up of three different members. We have fields, constructors, and methods, right? Okay, so these are the fields, which are variables owned by the class. Okay, and we have private in front of these guys. What does private mean? We have three different things we can put in there: public, private, protected. We haven't really talked about protected since we haven't done inheritance yet, but so really public versus private. What does putting private in front of here mean?
We can only access them with the setters or getters or any other method in the class that has access to them.
Okay, so officially what private would say is we only have access to these guys within this particular class, right? We only have access to these guys within this particular... You're a little bit late, aren't you?
I blamed the Starbucks line too long.
You know they have an app where you can pre-order the stuff. You can pick up my coffee like when you just walk in and say, hey, I'm here for Dr. Lippman's coffee.
I'm just kidding. Because,
These students are just underperforming.
Because I'm a worker, go wrong, go like so.
I'm just giving you a hard time. Thank you, I appreciate it. You still
If I'm
gonna...
not bringing coffee, you're gonna say, hey, you're gonna lunch drive for your brother and you go late, right?
Well, I already gave him a hard time about that. He said, actually, in his defense, in Bakari's defense, he was asked, it was your older brother? Okay, so he was asked to take his older brother to work today, and he turned him down. He says, "No, I got to go to class." Right? Is that the way it went, or it was like you just didn't want to take him?
I'll leave it up to
All right, so you didn't really care if you skipped class or not. You just didn't want to take him to work. All right, message received. I got it. Got it. All right, so private specifically says we only have access to these guys within this class named player. The side effect of that would say if we want to have access to that guy outside of this class, we would need to provide getters and setters for providing that read or write access. Make sense? So getters and setters are our modern name. The old school name would be accessors and mutators. Nobody uses those names anymore, but from a history perspective, since I kind of like connecting those dots to older languages, know kind of where these guys came from. All right. There's a 99% chance that I would never ask you on a test or something like that, like what's the name, what's the prior name to a getter or something like that, for to look for accessor, but kind of know it for trivia stuff. Yeah.
Do we have a midterm?
Yeah, you do. We'll talk about it. Yeah. It's not till after break, obviously. So everybody clear your desks. See, rather than having the stress of studying, I like to just drop it on you.
Rather than having you waste your time studying and still fail.
Yeah. Why spend a whole weekend just to come in and fail the exam when you could just show up and fail it? Right?
You're saving us.
All right, so, here, I'll just mention it right now then. So the exam, we don't have class Thursday, right? So that fall break starts 4 p.m. Wednesday. That means if you have a class before 4 p.m. on Wednesday, you should show up to that.
Sure.
Right? I don't teach on Wednesdays this semester, but I always give quizzes on those days. I got to be there. You guys should be there too. Unless you're going to an interesting place that has like a food item that I like that you're going to bring back as an offering. Yeah. Well, no, like we had one student last year who his family is in Cincinnati. Have any of you ever been to Cincinnati? Nobody in here's ever been to Cincinnati?
Who would want to go to Cincinnati?
Oh, well, there's one food you have to have in Cincinnati. Skyline Chili. Skyline, oh yeah, okay. Well, hold on. Keep in mind that now this is going to be on the midterm.
Was it Nickel?
It is, yeah. Okay, well, this is effectively it. So Skyline Chili does its chili three-way, but they have, so this is like, I don't know, maybe a half a pound of cheese on top of it. But the important stuff, their chili there is this like secret recipe since, I don't know, 50-year-old secret recipe. And so the chili is kind of like a looser chili, so it's almost like a sauce, but it has a really unique taste. Like it doesn't just taste like Hormel chili or something like that. The theory is it might have like chocolate in it or something. It's really good. And they call it Cincinnati styled chili, and there's a couple of competitors there, but there's probably 40 locations of Skyline Chili in Cincinnati. It's kind of like Chicago's Portillo's. It's like, and it's legit.
Portillo's is betraying Chicago.
Huh?
Portillo's is betraying Chicago.
Well, they have to. So there's where I live during the winter is down in Fort Lauderdale, and there's a Skyline Chili down there. It was one of the reasons that I picked the place. Walking distance to my condo, yeah. Totally legit. I'll tell you what, I'm on a low-carb diet, and I guarantee I'm eating spaghetti every day when I'm down there, so it's not going to work out well. But yeah, so he brought me back like four jars of Skyline Chili. Now, that gets you out of a quiz. I'm just saying, right? You could say, well, you can't treat students preferentially. Well, I did. So,
It's called bribery.
and trust me, it did not help him. His attendance is worse than yours. Any of you know Hinkle?
Yeah, he was my roommate.
Yeah, I like Hinkle, but man, crappy student. Smart guy though, just like Bakari. Yeah, just checks out. I like Hinkle personally. He's a good guy, and he brings me chili. So it's a.
I'll bring you some Portillo's next time I go home.
Oh, I do like Portillo's. Yeah, I like the Polish sausage and the Italian beef. Oh, yeah. Both of those.
Jumbo dog.
I mean, it's good, but you know, I think you got to get the Maxwell Street Polish, and you got to get the Italian beef. I think the jumbo dog is like, you know, it's third or fourth or fifth on the list. It's.
You ever have the chocolate cake shake?
I haven't had the chocolate cake shake, but I've had the chocolate cake.
What they do is they just make a chocolate shake and they just like cut off like a chunk of it and put it in there and mix it with it.
Oh, that sounds pretty legit.
It is until it gets stuck in the straw. Then you're like, ah.
Well, most milkshakes anymore get stuck in the straw. They're all too thick these days, right? I mean, it seems like it at every place. All right, so anyways, we don't have class on Thursday because that's our fall break, and then so we're back on Monday. Well, we're back here on Tuesday, but you have to come back to school on Monday, right? So our exam will be that Thursday. All right, so we'll review for the exam on that Tuesday. I'll go through all the slides, and kind of what I like to do is I go through and say, yeah, that sounds like a question I'd like to ask or something like that, because I'm going to go through it. I haven't written the exam, so I'll go through it just like I would write the exam, and things that seem interesting to me, I'll say out loud to you that, hey, this sounds like a good topic that I would probably try to come up with a question, so you can kind of focus in on where your studying comes from. So we'll do that on that Tuesday. Thursday will be the exam. You'll have the full time period to take it. You know, programming exams are usually hard exams. The exam will be mostly programming. So usually my exams are like 10 questions. I would expect 5 of them to be programming. Some of them smaller programming chunks than others. If you completely bomb the first exam, which some of you will do, I mean, that's just the nature of programming. Sometimes it just takes you longer to catch on than some other people. My policy is if you do well on the final, if you do better on the final exam, I'll replace your midterm exam score with whatever you got on your final. So a 0 and an 80 turns into an 80 and an 80. Okay? I won't go the other way. So you can't get 100 on the midterm, not show up to the final, and expect 2 100s. That doesn't work. Okay, but I do give you the get out of jail free card if just the midterm just doesn't go well, because it's just the stuff isn't quite clicking yet. Make sense? So my view on the midterm is it's mostly about kind of telling you where you are relative to where you should be. Something like that. So I want you to go into it. I mean, I want you to prepare for it. I want you to go in and study hard and all that stuff. But don't completely flip out if you walk out and feel like you didn't earn points. Use that as a reason to focus on where are you weak, and then start thinking about improving in those areas. Make sense? All right, because at the end of the day, my job is to give you a grade at the end of the semester that indicates how well you've mastered the material, not, you know, how badly did you bomb an exam on one day. Make some sense? Don't you wish other teachers did that?
Yeah.
I mean, you'll still like bomb my class because all my exams are hard, but at least it seems like I give you a fighting chance. Jerk, right, Bakari? See, Bakari could technically skip the midterm and still do well in the class. As long as you can't skip the final, too. You got to show up. Probably show up to that one, but if there's a priority. All right, that makes sense?
I think you gotta do some laundry.
All right, so we'll go through a review for the exam on a week from today, on Tuesday. And so if you want to come with questions, if there's ideas that you want me to review, go over again, blah, blah, blah. And then should I give you a ridiculously hard homework assignment to do over break?
No.
All right, we'll have to see how well participation is during the rest of this class then. We'll just have to see.
Everyone no one hardly wants to answer wrong, right.
Just wrong or right doesn't matter. Just say something. Just participate.
Something.
All right. All right, so this was our constructor. Private means that we only have access to it within this class. So my recommendation is just to lock fields down as, basically make them private first. And then if you have a legitimate reason for loosening those reins, then do it. It's just considered good programming practice. Now, having said that, if I'm writing a quick little object just to store some stuff and I'm the only one who's ever going to use the code, sometimes I'll not put private in front of it just so I can directly access those variables as a quick convenience. But if anybody else might look at your code, work with your code, it'll be in your best interest to write well-formed code, make things private, provide accessors when you need to have access to them, that kind of stuff. Okay? So here's some other examples of, here's a getter for our rating. So we're returning this private member as an int through a method called getRating. Is there anything special about getters and setters compared to other methods? Or is it just what they do? Yeah, it's just what they do. So there's nothing unique about getters and setters compared to other normal methods. They just happen to typically be named get field name, and they typically will just return the value of the field. Similarly, the setters would be called set field name. They would take in a value, and then they're going to have logic in there to set the field under maybe some sort of oversight. You can't set it to a negative number, that kind of crap. But other than that, those are just naming conventions. They're no different than any other method. All right, go ahead.
Last time when you made the setters and getters, you opened up another window. How did you do that?
All right. You didn't memorize it? It's just garbage. All right, so here, let's get rid of getRating here. Well, actually, do I have it for all of them? We'll get rid of getRating. So you just right-click out here. And I think if you right-click on a word, that might not work. Oh, it does. So right-click anywhere out here. You go to Source. Then you go to Generate Getters and Setters down here. And it shows you all your fields up here. And I got rid of the getRating. So you can do a getter and a setter just quickly by clicking on the whole box up there. But if you want to be specific about it, just go to the field you want. We're going to do getRating. All the other stuff down here gives you some control over it if it's important to you. So for instance, you can make it public, protected, package, blah, blah, blah. Some of these things aren't even meaningful to getters and setters. I think this is a generic form that they use for other things in here. So I'm going to say 99% of the time you're not going to touch anything else in here. In fact, it might even be 100% of the time. I'm not sure if I've ever done anything in here. It does allow you to kind of choose where it might fall in the code, but I never touch anything down there. So just hit OK, and it goes ahead and throws that method in there. Make sense? So a little convenience thing that a tool like Eclipse will do for you. I don't need that guy, do I? Oop. What just happened? All right, good. Okay, so now for our homework assignment, we were to go back and take our soccer deal. Do I still have that in Slack somewhere? We did have it in Slack, didn't we?
Yeah, I think it's there.
What class is this? 250. What chapter was that from? Oh, that's gonna go. Is this it was chapter 6? No. Yep, this is the guy. What do I do? Edit in new window. All right, perfect. So we can steal some of this here. All right, so I think we created a function somewhere in here for our show menu, right? So let's go ahead and we'll steal that guy to make our showing our menu convenient. What does it mean to have static in front of a class member, either in front of a field or in front of a method? as opposed to us not having static in front of these fields, not having static in front of these methods. What's the differentiating factor between having static versus not having static? Good.
If a method has static in front of it, it's going to be a class method, and you'll want to call it with the method name, and then the name of the dot, and then the name of the function or method.
The class name followed by the name. Yeah.
Sorry.
So static means it's owned by the class. It's a class member. So a static variable, static field, is owned by that class, not an instance of the class. A static method is owned by the class, not an instance of the class. Whereas these fields here are non-static. So these are instance fields. They are owned by instances of the player class. So if I have two different players, each player will have their own copy of jersey number and their own copy of ratings. So those variables are duplicated on a per instance basis because they are non-static. That make sense? Things that are static only exist one time. They are owned by the class itself. We don't get multiple copies of that if we create multiple instances of that class. Think of it like a factory. Okay? So we'll go ahead into our driver here, and I have this show menu. Show menu goes in. It shows our menu for this guy and returns a char. And the char it returns is the character at bucket 0 of the our scanner. Okay. So this will show our menu, blah, blah, blah. Now, initially, we're supposed to fill up our, oh, I must have opened it up in, there we go. So what we did up here first, in fact, let's just, why don't we just steal this code? Was this our starting point? Is this our solution to that homework that I put up?
Yeah.
Okay. So why don't we just throw that in here, and we're supposed to objectify that and make it, oh, here, let me show you something else interesting here. See how the formatting is all off? I think I showed you this one other time too. I'm going to go ahead and highlight it all.
I think at one point you had us make it modular, and it doesn't look like this.
Well, this isn't the modular one. I don't think I wrote the modular one, but we'll make it modular as we're doing this. So I'm going to right click here, and I'm going to go to, I think it's under source, and then we're going to say correct indentation. You could also just do on a Mac, it's Command I, on a PC, it's Control I, and that will shift everything over to clean up your indentation and that kind of stuff. All right, so right off the bat here, if we look at the very top, we had our parallel array solution to this problem, right? So we had two different arrays, each holding 5 elements. One of the arrays holding a bunch of jersey numbers, the other array holding a bunch of player ratings. Well, what we want to do here is we want to convert this to be an array of player objects. So I'll go ahead and write this above that first, and then we'll delete that code. So we're going to say a player array, let's call this guy players, is equal to a new player array of size 5. So I've created an array capable of holding this many of those guys. Make sense? Now, are there any players in there yet? Nope, no players yet. But I have a nice container for holding those players. Okay? So now we'll go ahead and kill off these guys. All right. So this is where we were going through and reading in our player information, right? So I'm going to go ahead and cut this. That way I have access to it here in a minute, and we'll just modularize that while we're at it. So we're going to say static void get players, and this guy will take in a player array. I'm going to call it P there just so I can show a point. Usually I would call that players, but I want to emphasize a point here in a second. All right, and we'll go ahead and paste that code in here. All right, so this guy's going to take in an array of players. We want to go through every element of that array of players so we know how many players we're filling in information for, right? Okay, in this case it's 5, but we would refer to it here as P dot length. That's the number of buckets available in my array called P. Make sense? Good with that? All right. So then give me the player information. So we are reading the stuff directly into our arrays here, but we actually need to get both pieces of information before we can actually build our player object here. Because our player object is built in terms of the constructor requires us to give it both a jersey number and a rating. All right, so we need to read in both of those pieces of information, and then we can build a player object and put it into our array. So I'm going to go ahead and we're going to say int jersey number, int player rating. Oop. One key off. There we go. We'll go through every element of our array. We're going to set, actually I can just do that. So I'll set our single integer variable here, which is a local variable inside of our get player. So this guy lives and dies with this method. His scope is local to the get players method. So I'll read into jersey number our next value. Oh, I need to give myself our scanner, right? I didn't define the scanner up there. That's fine. We'll just define it up here real quick. Scanner input is equal to new scanner system.in. Okay, so now we have that guy. So we'll read in our next integer, store it in jersey number, read in our player, store it in player rating. Then we're going to go ahead and we're going to say P at bucket I. So we're going to fill in our player array with a new player. Is going to be equal to a new player object built using the jersey number and the player rating. So this creates a new player and returns for us the memory address where that player exists. We're then going to store that memory address inside of bucket I of P, which is the player array that was passed in. Make sense? All right. So this will happen in this case 5 times because that's how many buckets we built into our player array. All right. This guy is called get players. He returns nothing. And he has static in front. Static means it's a what? This is a review from 5 minutes ago. So it's owned by the class. And how do we call static methods? In this case, driver, we call them using the name of the class in which the method was defined. This method, this is the method definition here. This method was defined within a class called driver. Therefore, we'll call it by saying driver dot get players. The name of the class is driver. The name of the static method is get players. So we'll say driver dot get players, and it wants us to pass it a players array. I'm going to go ahead and pass it players here. My question is, has our players array actually been filled? Doesn't sound like good grammar, is it? Is it? I mean, you were a psychology major, so you're probably better at writing and crap, right?
I'm pretty good at writing.
Yeah, so I mean that I'm not there. Yeah, it's a weakness. So we're gonna call it perfect because I'm the teacher. And I would never teach an English class, so we're gonna say it's good. So the question is, has this player array, the guy we built right here, that we then passed in as a parameter to get players, which we wrote down here, and the parameter we took it in as is something called P. Have we actually filled up our players array, or did we just waste our time? Well, okay. assuming get players gets called, and assuming we go through this whole loop and the user entered in five pieces of information for players, at the end here, we're not returning anything because this method returns nothing. What I want to know is after this method runs to conclusion, have we actually filled up our players array up top? Or have we just filled up P locally, and once this method ends, has that all been lost? If you want to put it more generically, have we done this correctly, or have we actually just introduced a bug where we wasted our time trying to fill up an array that we didn't intend to fill up? So when I call this guy, I'm creating my players array here. I'm passing players in as a parameter. Players is coming in and is linked to a variable called P. So P would be a synonym for that guy. Then we're going through here and we're filling up P with information. So the question here is does the changes we made to P persist beyond this method call? And this ultimately comes down to side effect. Is players passed by value or passed by address? What's the difference? If I say something passes by value versus passes by address, what's the difference between those two? In terms of semantics, in terms of side effect, something like that, however you want to explain it. I notice this, we're already kind of reviewing for this exam. Go ahead.
When you pass something by address, you're going to get the physical memory address to it, so when you pass it and it gets changed, it's going to have side effects throughout your program.
Yeah, we're changing the real deal, right? So when we pass it by address, we're changing the actual thing up in memory. But
When you pass value, you pass a copy of that.
yep. All right. So if I gave you the address to my house and you ran there and spray painted my garage, when I get home, I'm going to be in for a surprise. You spray painted the actual garage, right? Okay. But if I give you a quarter, I have 2 quarters in my pocket, and I give you one of them, and you go and, I don't know, spend it or melt it or something, you do something to change that quarter, that's not going to have an impact on the quarter that's in my pocket, right? I gave you a copy of the quarter, and you went and worked with that. So that did not have an impact on what was in my pocket. So I gave you that quarter by value. I gave you a copy of the quarter for you to do whatever you're going to do with it, and any changes you make to that quarter have no impact on the original. I mean, it would be real Houdini stuff for me to actually do a copy, right? Like hold the quarter, right? Get it, and then the original went back in my pocket. But you know, man, that would be like, I mean, it would be like a really cool talent, but kind of an inconvenient talent. If only all you could do was duplicate quarters. I mean, you just, every place you go, you're just paying with a pile of quarters. I mean, it's like free food and free stuff. But I mean, you go in, you know, the new Xbox comes out, and you know, well, what's an Xbox? $300, something like that. Yeah, I mean, they're just a big pile of quarters. And I go count them.
Nobody's done recording troubles. They're gonna show you that change machine and you can go over there.
You have to bring one of those portable change counter things. That's actually an interesting question. Would that be a power? I mean, I think it's a power we'd all want because it's free money, right?
But you get tired of it.
Yeah. I mean, you'd have to you basically have to go sit in the parking lot of a bank. Like, give yourself your allowance for that week. Go in and convert it to temp bills. And then you can go spend money, right?
And you probably want to alternate banks, because otherwise they're going to be like, what's up here?
It's like, where's this guy getting the quarters? Well, I mean, I guess if you want to really, like, you know, play it out, you know, just kind of dress like, you know, a little bit like borderline homeless and kind of walk in and have everything in a tin can.
You baked it.
Well, I mean, you could even do this on a daily basis, you know, just the guys coming in and it's like, hey, the guy at the alcohol shop, you know, they're not called alcohol shops, are they? What are they called? Liquor stores. The guys that you guys understand that I'm a computer scientist. Other things in real life make little sense to me. The alcohol shop.
The old alcohol shop.
Yeah, he's just not taking my my coins. Man, how did we get into inventing? Oh yeah. Pass by value. It's like being able to magically recreate quarters. All right. Yeah, that'll be the midterm exam. You can either answer all the questions, or if you can come up and duplicate 10 quarters on the fly. I mean, not just pull them out of your pocket. I mean, just duplicate quarters. A for the class. Guaranteed. And then we'll talk on the side because we can have an arrangement. All right. So this guy is an array. Okay. Are arrays passed by value or are they passed by address? He just explained the difference. Passing something by address means that we get the location in memory where the guy lives. So when we make changes to it, those are permanent changes that do have side effect that everybody else is recognizing, right? If we pass something by value, we're just manipulating that copy of it, just like the quarter example. So are arrays passed by address or are they passed by value? They're passed by address. All right, so we are getting the address of this variable p, which is linked to our variable players here. So players has a memory address which matches the memory address in P because those guys are the same. They're two variables that both point to the same place in memory. Okay? So that's why I named this guy something different, so you wouldn't think that they were actually the same thing. All right? I would probably name that players here in my constructor, or in the method header, and then refer to it as players down here. Oh. All right, that way we gave some meaning as to what value are we passing in here. We're passing in our collection of player objects known as the players. Okay? So this guy should fill in our array of players. And since it does have side effects, since it was passed as an address, that's what this guy will do. All right. Then we're supposed to start reading in some options. So what we could do, I guess, is we could take our option code here and move that into its own function and then return, so we can do something like, we have our show menu, so we could take all of this stuff, let's say all of our options, and we could put that into a function called process option. Now this guy's a char. Are chars passed by value or passed by address? It's a primitive type. Primitive types are passed how? Value or address? By value. It's like a quarter. So when I throw option in there, even though we're not going to be changing option, if I were to change the value of option here, it would not have a global change. It's local. All right. So even though I've named this variable identically to the variable that's up here that I'm probably going to be using, okay, this guy would not. They're only linked to each other in terms of their value and their name. They're two different things. This guy is one quarter. This guy is a completely different, although identically looking quarter to begin with. Make sense? All right. So I'm going to go ahead and paste the code in here so I don't forget. So what's this guy going to do? He's going to take in, well, right now he takes in nothing. We're going to have to pass that something else here in a second. And he's going to process that option. So if the option was U, then we're going to do some stuff here. If the option was A, we're going to do some stuff here, so on and so forth. Okay? Now, we're going to go ahead and not only take in the option, in fact, we can actually probably read in the option here. Yeah, let's do that. Let's not take in the option here. Let's take in our player array, call players. And what we're going to do is we're going to say, we're going to steal this line, drop it in there so we have our option. We'll then steal this line. So now we have a method that is being used similarly to, and actually we can do this. So we have a method that's being used within another method. So this goes back to how all programs begin and end with main. So here's our main method here. Our main method somewhere in here. Let's actually, I'm going to get rid of this do while here for right now. We'll rewrite it here in a second. So we're going to say driver dot process option players. It's already in there, but whatever. So main tells us to call process option. Process option then has this call show menu. Make sense? How we've changed direction to this method, and then this method changed focus to this other method, which then comes back, we pick up where we left off here. All right, so not all of our methods need to be called from within main. Just main gets the ball rolling. All right, so we'll go ahead and call process option. We might change this a return type, but for right now we'll leave it. So we'll go ahead and read in a single option. If the option was you, we're going to do some stuff. What's the stuff we're going to do? Let's just grab this code. This is update player. So I'll steal that code. I'll go ahead and write static void update player. And I'll have this guy take in a player array players as well. We'll paste that code in there. What player would we like to update? We're going to read in a jersey number. We're going to have to give ourselves that scanner. I think we made those global before, but we'll make everything self-contained right now. All right, so we have our scanner. We'll read in the jersey number. Okay, now we're whipping through our jersey number array, but instead of doing that to find the jersey number, we need to go through our players array. All right, so this is players. So for I is 0, I is less than players, I plus plus. If jersey number, the value we just read in, is equivalent to the current players jersey number. How do I get the current player I'm looking at's jersey number? We look in player, jersey number is a private variable. So I can't just say this. I can't say players at bucket I. That guy is our current player, right? That is the current value inside of players, the players array that we're looking at. And players at bucket I, what is the value of players at bucket I? Somewhat of a trick question. What did we say? Okay, wrong answer. He fell for the trick. Okay. Well, player is a synonym for the whole object. I knew what you meant. Still the wrong answer. That's okay. I mean, it's the right answer to fall for my trick. So I was hoping somebody would give me the answer, and you were my fall guy. What's the actual value of what I have highlighted there? Memory address. It's a memory address which points to the actual player object. Does that make sense? Okay, we filled up players up here. Where did we fill it? Down here? Farther down? Get players. We filled up players with a new player object. So here's our constructor, and that constructor went and built us a player, but returned for us the memory address where that player was stored. Make sense? So players at bucket I, up here, wherever we are, this guy right here is the memory address which points to the player in our array. Make sense? Now, realistically speaking, from a problem-solving perspective, it's okay to think about this as, oh, that's the player. That's the current player we're looking at, even though what I'm trying to drive home is this idea that it is, in fact, the address that points to the player. At runtime, it will get resolved, Zach, to the actual player. So, I mean, you're still wrong from the question I was asking, but it wouldn't have hurt you in programming because ultimately it will be the player. Make sense? All right, but just you were wrong. So you're.
Who's scared? You just answer the question.
I had his older brother in class. I like Zach a lot better. Don't you like you better too? Yeah, I mean it's not even close really. Except his older brother had a better name, Abraham. We called him the patriarch. Get it? That's Christian worldview right there. Point. All right. All right. So now this is our player object, our pointer to our player object, which will ultimately get the player object. But I want to get that guy's jersey number because I want to find out if the jersey number we just read in is equivalent to the jersey number of this particular player. And when we go into our player object here, we notice that we made jersey number a private variable, which means we only have direct access to that variable inside of the player class. Now, here I am inside of the driver class, not inside of the player class. I have a player object sitting in front of me, okay? But, think of it like some kind of weird puzzle thing. I can't get the jersey number directly from that guy. So how do I get the jersey number from that player? Yep, using the getter or the accessor method that we wrote. Make sense? So I get a player's jersey number by calling his public get jersey number method. Now, is that a class method or an instance method? Instance method. How do you know? No static. We do not see the word static out front. That means it's an instance method. It's an instance method. And how do we call instance methods? We call class methods using the name of the class in which the method was defined. We call instance methods using an instance of the class in which the method was defined, an actual object. So out here, we have an actual object here. A pointer to that object. He'll become an object. And we can say, I want that guy's get jersey number. So we're using an instance of the player class to call that particular instance's get jersey number. Now, why did we make this an instance method instead of a class method? When we wrote get jersey number, why did we make that guy an instance method? Similarly, why did we make these fields instance fields instead of static fields? Same answer. Why did we choose to do that? All right, so without actually answering it, raise your hand if you think you know the answer. I'm truly trying to measure where the misunderstanding might be. Just loving this confidence right here. Yeah, for the record, we had 0 hands up. We had a whole lot of halvesies, right? All right, so like 5 people think maybe. Anybody want to take a stab at it? Why we made it's actually a critically important concept. So let's go ahead.
Is it because, like, if you would have made it with static, you would only be able to use it in the class?
Okay, well, so that is a true statement, that if we made these guys static, we would only be able to, well, you actually could use it outside of here, but I don't want to go down that can of worms. But you would be limited on where you could use it. There's some truth to that. But what we're looking for is the reason, the rationale why we chose to make these guys instance variables as opposed to making them class variables. There's a rationale behind that. I mean, it wasn't that we flipped a coin and decided, oh, we'll make these guys instance variables. If we made these guys class variables, if I threw static out in front of here, all would be lost for us here. Our logic would break down real quick. There is a distinct reason why we chose to make these guys instance variables. Go ahead.
Because we don't have static in front of them, every time we create a player, we will have a jersey number and a rating for that player, and we would be able to use the setters or the getters
Yeah,
for that.
absolutely. So let's put this in some real life example. We're going to take these 2 rows here. These are my 5 players. Okay, just because we happen to have 5 people here. There's only 4 there, so the site is obviously better. Okay, so here's our 5 players. As we have it right now, with these guys being instance fields, he has a jersey number and a rating. He has a jersey number and a rating. He has a jersey number and a rating. She has a jersey number and a rating. She has a jersey number and a rating. They each have individual jersey numbers and they each have individual ratings. If I were to make these guys static, but then I still created instances of the player class, so we still have 5 players here, they no longer have individual jersey numbers and ratings. There is only one jersey number variable owned by the entire player class. There is only one rating owned by the entire player class. And as individuals here, as instances of the player class, so he would be an instance, he would be an instance, he would be an instance, she would be an instance, she would be an instance, okay? As instances, they do not have access to that variable because it's not part of what they know about themselves. They would have to think back and say, you know what? All players have a jersey number. And then they could ask the player in the sky, the blueprint, say, well, what was the measurement of the garage? It's like, oh, it was 18 feet wide, something like that. Each house doesn't need to individually know what its measurement is. It might have a measurement, but you would go and look at the blueprint to find out what that measurement of the garage width is. Now, which makes sense for us? If we have a collection of players here, does it make sense that he would have his own jersey number and his own rating, and that he would have his own jersey number and his own rating? I mean, that's how the real world would work, right? Otherwise, logic breaks down here, okay? So we need these guys to be non-static fields because we want every single instance that we create of players to have their own jersey number and rating, their own jersey number and rating, so on and so forth. That makes sense? So by making these guys non-static, by making them instance fields, every single instance of player, every copy of player will get their own version of each of these instance members. Their own version of the instance fields, own version of the instance methods. So for instance, this guy down here, the get jersey number instance method, because it does not have static in front of it, this instance method is owned specifically by this player, He gets his own copy. And his copy knows about his jersey number. His copy knows about his jersey number. That make sense? Okay. So is it clear why we made that decision? It's not a coin flip. It's not like, oh, well, they're both good. Static, non-static. Sometimes I like to use static. There's a rationale behind it. Okay? Typically, when we're writing variables and stuff like that at the class level, inside of the class that has main in it, we're making those static because we're kind of using those as global variables owned because we only have one copy of our program running, right? So only one guy that has main inside of it exists. So we only need those variables to exist one time. Having said that, that program is working with a collection of players. So each of those players is an individual instance of that player blueprint, that player class. All right. So down here, where are we? Didn't I start writing method somewhere? Nailed it. Okay. So here's our player object, and we're going to call that particular player object's get jersey number, which knows about his particular jersey number. Sound good? All right. So if the jersey number we're looking for matches the jersey number of the player we're currently looking at, then we found the player, print out what's the player's new rating, and we're going to go ahead and this is the new rating we're reading in. I want to set the current player's rating equal to the new rating we just read in. Once again, come back here. Rating is a private instance field. So we cannot access it directly because it's private. It's only accessible within the player class. Okay? It's an instance field, so every player has their own copy of it. And we will go ahead and set it by calling our setter that we wrote, where we'll pass in an integer, and it will do its logic that as long as you put in a rating greater than or equal to 0. Okay? You can't make a player suck so bad that they have a negative rating. Right? Well, you maybe could, but you can't. By our code, you can't. All right, so we'll be back out here, and we're going to set player. I'll just do players at bucket I dot set rating to the rating that we're going to read in. All right, so here's the player. We're going to set that guy's rating to whatever value we pass in, which is the value we just read in. All values resolve. Well, it's actually the wrong connection here. We have to wait for this guy here to actually finish resolving. This is a blocking line of code. So input.nextLine is going to wait for the user to type something in and press enter before it actually will resolve to a value. Make some sense? All right, so this is kind of a pause in our program. This guy can't finish being called until this guy that was passed as a parameter resolves to its actual value, because set rating here is expecting a single integer. And we're passing it a single integer, but we have to wait on the human being to finish entering that integer as part of that next int call. Okay? So this will set that player's rating, and then we're going to break out of, well, tell me, what does the break keyword mean? What does that guy do? Takes us out of the most local loop. For loop, while loop, doesn't matter, but it breaks us out of the loop rather than us having to play the counter trick by setting the counter to something that'll make the loop fail the next time through, breaking the logic. This guy just jumps us right out of the loop. All right, so because we're done updating that player. All right, so this guy is a class method. So when we call process options, if they say U for update player, we'll say driver dot update player, and this guy wants an array of players, which we'll pass him there. So we'll pass that array of players across. That's if we set option U. This guy here, what is the minimum rating? Well, this is for displaying ratings that meet some minimum thing, right? So we're going to call this guy static void display minimum player array players. We'll paste this code in here. We'll read in the minimum rating. Again, this guy's relying on an input. At this point, we could probably say, well, you probably should have made that guy global, but we didn't. So we'll just create another scanner here. And this will actually be, I think I might even recommend this approach. I'm a fan of keeping things as self-contained as possible. That way you have things less strewn about your code. And it also then gives you an opportunity to type those same lines multiple times, which is going to be good practice for making less errors. Okay, so we'll create another input, which is a new scanner. We'll read in our minimum rating we're looking for. We're going to go through all of our players. So it's no longer called jersey numbers. Now it's called players. And then if our current player, players at bucket I, dot get rating is greater than or equal to the minimum rating, then we'll print out the jersey number for that guy. So this is players at bucket I dot get jersey number. Minimize that guy. And this is players at bucket I dot get rating. That's how we access those private fields of that player object, by calling their getter methods that we wrote. Okay. So we converted that guy to use objects. That's display minimum. So this will be driver dot display minimum players. Okay, so this is our replace a player, right? Steal that. Static void replace player. Make this guy self-contained. Scanner input is equal to new scanner system.in. What player would you like to replace? Read in the jersey number. Go through all of our players. If the jersey number that we're looking for is equal to players at bucket I dot get jersey number, then we found the player we want to replace, so we want to read in our new jersey number. So we can actually repurpose this and say int rating. So we'll say jersey number is going to equal to the new jersey number we read in. So notice I'm repurposing this variable. I've already used it to detect that we found the right jersey number. Therefore, I can go ahead and use it again because I know I'm going to break. If you're not following that logic real well, that's okay. You could always just do a second variable jn, read in jn here, then you don't have to worry about having a variable mean two different things because you already finished using its first use. So we'll read in the new jersey number, we'll read in the new rating, and then we'll say players at bucket I is equal to a new player, passing it jn and rating. So we'll build a brand new player and overwrite the player that used to live at bucket I of players. Make sense? We've replaced that player. So what happens with the player that used to live at bucket I? Okay, so here's our real life example. This is our array here in these first two rows. Okay, now this is this a soccer team? Right? Oh, he told me he's a good soccer player. Okay, any of you suck at soccer? No. Out of this team, you're nowhere close to my team. Okay, you're pretty bad at soccer. You're out. He's in. Okay, so what I just did is I replaced. We'll say this is 0, 1, 2, 3, 4. So I replaced bucket 1 of my players array with this guy. All right. So brand new player. Okay, jersey number. Oh, you're 0, 0. Well, that won't work. We have to have an integer. Your jersey number is 0, but his rating is a 30. Okay, we tried to make you a -2, but we ended up with a 0. Okay, so because that was the So he's out. He's in. So now bucket 1 of our array has a memory address in it that points to him now. Okay, so even though he's not sitting here, he's in. All right, he's on our team. what happens to him? He doesn't have a home. Okay? He's no longer bucket 1 of our players array. What happens to him?
Player anymore. So probably Java's gonna get rid of him.
How is Java going to get rid of him? That's exactly right. Is there any way to get back to him? He only existed when we first read in our players here. Where was that? Get players somewhere down here. Get players. Right here, when we were at I is equal to 1, we created a brand new player. This is when he was born. All right? He was born and put there. Only one thing actually knew about him, and that was his teammates, the array he was in. But now, we've replaced that pointer. Okay, so he's just chilling up in memory, and nobody can actually get to that value. We don't have a programmatic way of talking about him again. And he says Java's going to get rid of him. How? How does Java get rid of unused memory addresses? Garbage collection. Okay, so his pointer count went from a 1 down to a 0. He had one thing that pointed to him before. But then when we created him and replaced him with him, his pointer count went down to 0, your pointer count went to 1. And things that have pointer counts of 0 are marked for deletion, okay, marked for garbage collection. So he's chilling up in memory, waiting, and it's probably one of those garbage trucks with the grinder on the front of it. Okay, I mean, really, I want you to paint that picture in your head. Okay, this is not gonna, this is rated R minimum. All right, so he's gonna, the garbage collection is going to reclaim that memory because it's not worth him existing. All right, that might have been Christian worldview, I think. Maybe? Yeah. All right, that makes sense, kind of what's happening? All right, so now he's in, he's out, and dead. Okay, soon, the garbage collection's running in the background, so he might be kind of chilling, just waiting for the inevitable. All right, so let's finish this up real quick in our last minute. Where's this option? What am I replace player? Okay, so there's our new player in players at bucket I. He's now floating around waiting for garbage collection to clean him up. Older languages like C++ would have required us to delete him, or we could have been nice and just let a memory leak happen. Okay, and a memory leak would have been like, we're going to let him float around in memory because we're too nice to let him be killed off, but nobody can actually access him, so he's literally a waste of space. Does that sound familiar at all? Just your dad tells you that? No. Because I run into your dad in the hallway pretty often, and I get a little bit different story. Yeah, no, you could say that about your brother, maybe. Too much sibling rivalry. All right, so does that make sense so far? All right, so why don't we'll pick this up on Tuesday after we review for the exam. I will not give you a homework assignment over break. Okay, so but I would still, between now and when you start going on break, if the stuff is unclear, we covered a lot of review stuff today. This would be a very good lecture to rewatch and review for that exam. Go ahead.
Why can't you just do like the players at bucket I and then reset the jersey number?
Well, you could, okay, but if we're doing the real life example of that, what we're really saying there is, okay, you, shirt off. Okay, here's your new jersey number. He's still not him, right? Yeah, I mean, we didn't put a better player in. We took the same player and just changed his jersey number. But programmatically, if for solving the problem, that wouldn't necessarily be incorrect. If we just updated his jersey number and updated his rating and just said, okay, you're new. Logically, that would work, but it doesn't match up to real life. Okay? All right, I will see everybody in 1 week. But make sure you show up to all your classes through 4 p.m. on Wednesday. Don't forget, today is student, faculty, staff Bible study. Go to the cafeteria, sign in, get your free lunch, God and grub. You can come sit with our computer science table if you want. And then we head down to the terrace room for Bible study.